Hello everyone, this is Gowthami. Welcome back to our YouTube channel. Thank you for encouraging me to upload a new videos. In this series, we are going to learn a new concept. Let's begin. So, importance of mathematics in machine learning. Okay, so usually it plays an integral part in machine learning. So in this mathematics, we are going to learn linear algebra, statistics, probability, and calculus. Remember, whenever you are learning these things in the machine learning, you have to know what there are three important pillars in this machine learning. Okay, ML is nothing but machine learning. Three important pillars. What are those means? One is the data, and second thing is a model, and third one is a training. So when you are using the machine learning, there are three main pillars. First one data, second one model, third one is training. So in order to understand the data, we will make use of the concept called statistics. So that is what I said, right? What are the concepts we will be covering in the mathematics? So we said linear algebra, the first one. And the second one here is, I said statistics. And the third one is probability.
Calculus.
And the fourth one is a calculus. I said these things, right? So I said when you are using the machine learning, three pillars, data, model, and training. In order to understand the data, what concept we will use here is statistics. We have learned already. A describe function will give the complete information about the table, data set. And also we have seen info function, shape, this and all we have learned. That and all in the pandas library only. So that and all comes under statistics. There are few more functions just similar to these functions only we are going to use in the statistics concept also. Okay, and in the modeling, so in order to computate, okay, in order to perform some computations, we are going to use a concept called linear algebra. Usually model means what? What is mean by modeling? Modeling is nothing but what? For performing some kind of calculations. Okay, that is what computations. What concepts we will use here is linear algebra. Along with this, we are going to make use of some statistical methods also. And training. What is the purpose of using the training means? In order to get the result. ஓகே ஃபர்ஸ்ட் ட்ரைனிங் என்ன இப்ப நம்ம வந்துட்டு ஒரு கிட் கிட்ட போயிட்டு ஏதாவது ஒண்ணு சொல்லிட்டே ட்ரெயின் பண்றோம். இப்ப வந்துட்டு இப்ப யாரா இந்த மாதிரி பிக்சர்ஸ் காட்டும் போது இந்த பிக்சர்ஸ் என்னதுன்னு சொல்லணும்னா முன்னாடி என்ன பண்ணிருக்கணும் அவங்களுக்கு? முன்னாடியே ட்ரெயின் பண்ணிருக்கணும் அவங்களுக்கு. சோ அதே மாதிரி நம்ம கிட்ட இருக்கிற டேட்டா அந்த மெஷினுக்கு கொடுத்துட்டு அந்த மாடலுக்கு கொடுத்துட்டு ட்ரைனிங் பண்ணணும். ட்ரெயின் பண்றதுனால இப்ப ஏதாவது நம்ம நியூ டேட்டா கொடுக்கும்போது நம்ம ட்ரெயின் பண்ணிருக்கிறதுல இருந்துச்சுன்னா இட் கோயிங் டு கிவ் a proper output. Otherwise it will not give a good output. Okay, so in this training we will going to make use of, so see, in this training not only training is enough. Training mattum panna onnu mattume kadiyadu. So you should optimize the model also. For optimizing the model, we should use a concept called calculus. Getting my point? So this is what a main things that we are going to use. A probability is nothing but a likelihood. So whether the person is, we don't know whether that person is having a diabetes or not. So that is chances of having diabetes, chances of not having the diabetes. So that can be predicted with the help of a probability. Okay, so three things. For understanding the data, we will make use of the statistics. For performing some computations, we will make use of a linear algebra and statistical methods. For training the model, only training is not enough. Along with it, we need to optimize the model. That is done with the help of a calculus. Got it? Got it, everyone? What is the meaning or what is the things we are going to learn in the mathematics and what is the importance of all those concepts? Got it, everyone?
Yes, sir.
Yes. See here. So whatever I explained, the same thing I written here. Mathematics for machine learning refers to the branches of mathematics that are used to find the patterns and optimize models in the machine learning. The main branches are linear algebra, probability, statistics, and calculus. Probability deals with calculating the likelihood of events. That is what I said. And their graphical representations. Statistics helps to analyze and summarize the data, providing the information about the data. Please mute your mic. Linear algebra and calculus helps to manipulate the matrices, nothing but the plural form of matrix, and vectors, and perform optimization techniques. So we are going to learn in the algebra, the main concept that we are going to focus here is a scalar, vector, and matrix. These three concepts are very, very important when you are working with the data in the machine learning. Okay, so these are the things. Now, what is mean by linear algebra? Linear algebra is essential for many machine learning algorithms. That is what I said, and the techniques. It helps in manipulating and processing the data, which is often represented as in the form of vectors and the matrices. What is mean by vectors and matrices? You can ask here. So simple. Vectors is nothing but having any one thing. That means either it may be a column or it may be a row. That means we know matrix is nothing but what? Matrix is nothing but the representation of rows and columns. Okay. Then what is mean by a vector means either only row or only a column. That means what I'm saying, see here, like this representation, 5, 7, 6, just like an array, I can say. Just like an array. How can I recognize the array means? If the values are separated with the spaces, then I can say it like an array. So this is a vector having how many columns? 3 columns. This is represented. If you are going to find the shape, what is the output we will get? 3 comma. So if it is a one dimensional, it is going to give only the number of columns. For suppose if I am having something like this 6, 3, 7. So this is also one type of vector where it is having one column. Where it having one column, and if you find the shape, what is the output for this here is 3 rows and 1 column. Getting my point? Either only row, either only column, that one will call it as a vector. What is mean by matrices? Matrices is nothing but a plural form of matrix. So the collection of vectors, so we can call it like a matrix. So like this, 6, 7, 3, 2, 4, 3, like this. So where it contains rows and columns. Okay, what is the shape for this here? 2 rows and 3 columns. Getting my point, what I'm saying here, everyone? Yes or no?
Yes, ma'am.
Next, these mathematical tools make computational faster and reveal the patterns within the data. Why we are making use of these concepts here is in order to perform manipulations in a faster way than the normal kind of things. It simplifies the complex tasks like a data transformation and dimensionality reduction. What is meant by dimensionality reduction means whenever you are reading the data, in that data, there might be unwanted columns. Okay, or a duplicate columns. For example, the data will be similar in one more column also. Is it necessary to keep that column for performing some kind of computations? No, because whatever the output it is giving on that column, the same output will be seen on the duplicate column also. Yes or no? So we can omit it. So dimensionality reduction is nothing but just taking only the important features, nothing but the columns. By taking those, we are going to analyze that data. So to reduce the columns which are not important for our modeling, that is done with the help of an algorithm PCA. Okay, and optimization. Key concepts like matrix multiplication, eigenvalues, and linear transformations help in training the models and improving the predictions efficiently. By doing all these things, you can get the good predictions, means good outputs. Whenever you are training the model by just doing all these techniques and all, you will find the good output. Next
dimensionality reduction or examples dimensionality.
That is what I said, right? So if you are having a data set, okay, for example, if I'm having a data set where it having some kind of features is nothing but what columns. So for example, if I'm having a city and I'm having a state and I'm having a district and I'm having something like again I'm having something like city with the help with this, it's some other name, okay, and I'm having the output something feature name. So whatever the values you have provided for this city, the same values you are having in this column also. Is it necessary of keeping the same data in the table? No. So you can omit this one. So whenever you are removing the duplicate columns or unimportant columns from that data set, then we can make use of a dimensional reduction. In that, we will make use of a PCA. It is one type of algorithm.
Okay.
Getting? Got it now?
Okay. Yeah. Got it. So algorithm itself will determine which
Yeah,
one
you can.
to. Okay.
Okay. So what is the full form for this PCA is nothing but a principal component analysis. So what is the technique? It is reduce the number of dimensions. Dimensions is nothing but what? We'll say, for example, if your data set is having 14 rows and 6 columns, 1, 2, 3, 4, 5, 6 columns. Okay, let us assume like this. So if you are feeling it as an unwanted, you can reduce that column, right? So that's it. That is what? Reducing the number of dimensions in your data set while preserving most of the information. That is what the usage of dimensionality reduction. In that, we are using an algorithm called principal component analysis algorithm. Got it? Now?
Yeah, understood.
Yes.
Got it.
Everyone clear? Now, let's discuss. I already said that in the linear algebra, we are going to learn the three main concepts called what is mean by vectors, what is mean by matrices, what is mean by scalar. Scalar is nothing but a single digit. We'll call it like a scalar. That means, see here, if I'm writing 6, this is a scalar. See here, scalars are single numbers that scale vectors or matrices. Means if you combine these things, means if you are combining multiple values, scalar values into the vectors like this, 6, 7. If you're having 6, 7, 8, this is a scalar. This is also a scalar. This is also a scalar. If you are combining all these things, you can make it like a vector. To combine, if for example, if I'm having 7, 5, minus 4, so this is one vector and this is another vector. If you combine these two things, you can make a matrix. So that is what the difference between the scalar, vectors, and matrices. Understanding? So now see here, scalars are single vectors that scale vectors or matrices, often used in algorithms like a gradient descent to adjust the weights or learning rate, helping the model improve over time. So what we will do here is we are going to multiply the some kind of numbers. Means if you want to adjust the weights, so it's usually in order to balance the outputs, what we will do here is we are going to provide some constant values. That constant value like a scalar value. That is what a single digit. And what is mean by vectors are nothing but vectors are used to represent the individual data points where each number in the vector corresponding to a specific feature of the data set like age, income, or hours. For example, I can say like this. A person having 6 years of experience had a salary 25,000 like this. And a person having 15 years of experience having a salary 70,000 means this is what the representation of the vectors. This is what is this one? The first value representing experience. And what is this value representing? The salary. And also you can write it like this, combination. So if the person studies 6 hours, okay, his marks will be more. So you can make it like something like 99 like that. If he learns, means hours, study hours. Okay, how many hours he is studying? So if I'm making 3 hours per day, so the result will be like 70. If he is learning for 1 hour study, then it may be like something like 30 like that. So means you are just describing the features in the form of vectors. Understanding? You can make it like this. Means any single row or a single column should be present. Understanding? And matrices. Matrices are considered as a data storage units used to store a large data sets. For example, of all these vectors, you can make it like a huge data set. How? See here, I can make it like this. 6 years experience person having a salary 25,000. 15 years experience person having salary 70,000. Means you are just combining these vectors to make one data set or a matrix. Understood this one? Everyone?
Yes, ma'am.
Coming to the vectors. So where this vector having a both magnitude and the direction. So magnitude is nothing but value. Okay. Direction is nothing but in which path it is going on. Actually, to define this vectors, there are different approaches. Like computer science approach is there, a physical based approach is there, and a mathematical based approach is there. So in our thing, we are learning a mathematics for machine learning. That's why we are just using the mathematical based approach here. For example, this is my graph where a one vector, this is one vector, 2 comma 2 is nothing but where it having a row with 2 columns. And this is also one more vector having one row with 2 columns. Okay, so this is a vector and this is also vector. So what I did here is I just plotted in the graph. So see carefully. See carefully. So what I have did here, this is the x-axis value and this is a y-axis value. Correct. So in the x-axis, what is the value here? 2. So 2 and y-axis value is 2. So that's why I just made point here and I am just drawn the line from 0th axis. And this is one vector. This is vector 1. And this is the second vector. The values are -3 and 2. You know that -3 will lies left to the 0. Correct. So x-axis is -3 and y-axis is 2. So you pointed it here. So now tell me here, what is the magnitude of the vector? So before going to know about the magnitude, we just need to know the representation of the vector. How we can represent this in the form of vector? So 2 comma 2 we can represent the vector as 2i plus 2j. This is the representation of the vectors. So I is for what? X-axis and j is for y-axis. Now we need to calculate the magnitude. To understand more about this, for example, if a car is moving in one direction, for example, if a car is having speed, how much speed it is having? Something like 50 kilometers per hour. So we are just using only the how much speed it is moving. That means if you are providing only the speed, then this is called a scalar. For suppose if I'm saying if the car is moving 50 kilometers per hour in the north direction, then this is a magnitude and this is a direction. Both things I'm doing. This is called a vector. If you are providing only one thing, that is called a scalar. If you are providing multiple things, means the magnitude, this is called a magnitude and this is the direction, then we'll call it like a vector. Getting my point, everyone? Now, how to denote the magnitude? How to find the magnitude for this vector? That is 2 comma 2. How to calculate? Very simple. x1 square plus x2 square. So you just calculate it. That is 2 square plus 2 square. That is equal to, this is what? x1 and x2. So 4 plus 4, that is equal to root 8. So the magnitude of this vector here is root 8. And what is the magnitude for this vector? -3 whole square plus 2 whole square. That means 9 plus 4, that is equal to 13. The magnitude for this one is 13. And what is the direction we will see here is, usually we can come to know it is just looking like a right angle triangle. So when we are making it like a right angle triangle, we will make use of the thetas, okay, angles. For determining the angles, we will make use of the theta. So we need the angle for this only. So this is the direction where the vector is passing, means providing the direction from 0 to this vector. So this is a line, right? So I need to know the direction also. So you have to make use of the formula tan theta is equal to x1 by x2. That means x1 means what? 2 by 2, that is equal to 1. So tan theta is equal to 1 means on which degree it will give? 45 degrees. So the theta for this vector is 45 degrees. Same thing you have to calculate for this. Tan theta is equal to -3 by 2. So you need to calculate what is the value you will get it. That value will be that is the angle for this vector. Understood till here, everyone?
Yeah, ma'am.
So why I have explained this one, we are going to see why, because in order to perform some kind of manipulations on these vectors, we need to know first what is meant by magnitude and what is meant by the direction. Okay, so now we are going to perform some operations on these vectors like addition, subtraction, multiplying a vector with the help of a scalar value, and a dot product on two vectors, cross product of two vectors. That is now we are going to see. So for performing these operations, you should know about these relationship between the magnitude and direction on the vectors. Okay, so now let's begin vector addition. So here, this is one vector having a values 2, 3. That means this value is what? What is this 2, 3 here? 2 is lying on x-axis and 3 is lying on y-axis. So if you want, you can plot it here. So just write, we'll just write it here. So 1, 2, 3, 4, 5. And this is a 3. Okay, 3. So 2, 1, 0. 4, 5. So this is a vector which the first value will be like x-axis and second value will be the y-axis. And this is also one more vector. I just drawn the line here. So now see here, I just plotted the dot and you have given this line 2, 3. Okay, this is another vector. So the same thing here 3, right? So you just write it properly. Here I just didn't write 3 and this is -2, -1 and this is a -2. Okay. So when I perform addition, what is the value? You will get it here. 2 plus 3, 3 minus 2. That means 5, 1. 5, 1. So where you are going to get the value? On x-axis 5 and y-axis 1. Here you will get it. Yes or no? So you have to combine these things. So you will get the line in this way. This is the resultant vector. This is the resultant vector of these two vectors. Understanding? So next thing, we are going to perform the subtraction the same way. So if you are providing the same thing, you just plot the two vectors. With the help of these two vectors, you are going to get the one resultant vector. So try to do this. 2 minus 3, 3 minus of -2, that is equal to -1, and you are getting the value as 5. So the x-axis is -1. So where you are getting the -1 means you are getting here -1. And the value of y is 5. That means where you will get the value? From where you are getting the value? -1, 5 you are getting. Will you able to plot the line? So you are going to get the here. Will you make it here? So see, when you are performing the subtraction, okay, so what you should do here is you should reverse the second vector. That means this will become -3 and 2. You should make it, but you will get the output. But whenever we are doing here is, when we have a negative sign, we need to reverse the vector. Okay, first you need to reverse this vector so that this will become -3 and -3 and 2. These are the logics, ma. So see, 3 minus 2 is there. If you are reversing, this will become -3 and 2. So -3 will be the x-axis and 2 will be this one. So you are just drawing the mirror for this. Okay, now you can get the resultant output. What is the resultant output now? For these 3 only, for these 2 outputs, -3, 2. What is the output now? This one. This is your output. Got it? Yeah. Now see the implementation. Later I will discuss the remaining 2 of them. So for plotting these things, first you need to import the graph also. We need it. Okay. And we are performing some kind of manipulation, that is a matrices or vectors, that is comes from the NumPy library. And you want to visualize this more better. So we will use the Seaborn also. Okay. So now see, just to open the Eclipse. Just to open the Eclipse, which I already opened. What I need to do here is you need to import the relevant libraries for performing these things. So first I'm going to import the NumPy library as NP. Later I'm importing the matplotlib. Import matplotlib dot pyplot as plt. Later, along with this, I want to use a Seaborn also, so which will give a more more beautiful visualization. Seaborn as SNS. Now, just plotting. For plotting these vectors, we are making a use of a function. Just run this. For plotting this, we are making use of a function called quiver function. Okay, so this function is coming from the matplotlib. So see here, plt dot quiver function, and you provide the vector here. So here the value is, the vectors are passing from 0th axis. The vectors are, means this, the first vector is, this is coming from the 0th axis. So you should specify the vectors here. So it is passing from 0, 0, whether the first vector is coming from 0 and second vector is also coming from 0 only. Okay, so then I'm giving the vector as 4, 5. So this is the first vector. Okay, so now just to show it, plt dot show function, you can see one vector. See here, we cannot able to see the grid. Okay, if you want to see the grid, what you have to do here is you have to set it sns dot set function, so that it is going to set the theme for our plots. So just to run it, and again you run this one, you can see the grids. So here see 0 and 0, and the values is 4, 5. So x-axis is 4 and y-axis is 4. So here you are not giving the proper values here. So now what I need to do here is you need to set the values based on the given values, that is 4, y. So what you have to do here is you have to provide the scale units, that is an attribute. So provide scale units is equal to on x-axis and y-axis, right? So just to provide xy, and also you have to provide the angles. I said already you have to provide the what is that, magnitude and the direction. Magnitude is nothing but the units, angles is nothing but the degrees. So angles, so xy. Then you have to provide the scale. So whenever you are dividing that x-axis and y-axis, it should be 1 unit difference. Okay, understood? So I'm just giving the scale as 1. And if you want to make how many values, means if I'm running like this, you will get this kind of things. Okay, you're getting, but it is out of the line. It is out of the line. So now what I'm going to do here, you need to provide the x ticks. So limitations on x-axis, how many value, the range what should be, and y-axis what should be. So plot dot x limit, I'm just going to provide -8 to 8. Okay, and y-axis, how much the limit you want to provide, y limit, and you provide the range on how much you want. So now just to run and check it, you are going to see plt here. Can you see here 0, 0, then 4? Okay, so here x-axis is 4, and in between 4 and 6 you are having the value as what, 5. Getting my point, everyone?
Yes, ma'am. Purida, ma'am.
Yes,
This 0 is origin, 4, 5 is on x-axis, it is 4, and y-axis it is having this one. So if you want to generate some other colors also, you can generate it. For example, that means the color of the arrow is in black color only. If you want to provide some other color, you just to provide color is equal to B, then it will be like something like a blue color. So this and all very simple, you can do it. So this is one vector. So where it is for 4, 5. If I want to draw one more vector, you have to write the same thing again. Okay. So now what I will do, I'll just copy this vector and I'm going to paste it here one more time. And you just change the values. Let us give -3 and -6. So this is going to generate one more vector line. Okay. Minus, where it is -6. Now see here. So this is from the origin 0, 0 only, and minus means it is going to be like this. So x-axis is a -3. That means here. -6 means here. The line is going to be plotted here. Okay, just run and check it. So now see here, it is going to be plotted here. Yes or no? So this is how you will plot the vectors using this quiver. Now what I need to do? You need to perform operations. The first one I want to do here is addition of 2 vectors. So if you want to perform addition of 2 vectors, you need 2 vectors here. You need to generate 2 vectors and you need to sum up all those things. So first what I will do, I'm going to create 2 vectors. So V1 using the NumPy library, V1. So I'm just increasing np dot. I already said array is a kind of an, vector is a kind of an array only. So as array Okay, as array, you just provide the values. 0, 0 is an origin, and I'm just giving 2, 3, what I have explained for the graph. So that only I'm giving for performing the addition of 2 vectors. So the first vector is 2, 3, and the second vector is 3, -2. So this is the first vector, and the second vector here is, so what is that one? -3, -2. 3, -2. Now what I'm going to do, I want to perform sum. Sum is equal to V1 plus V2. Okay, just to print that result. So once I print that result, later I'm going to show the representation. Something here, what? So V2. So V2, just run it. So see here 0, 0, 5, 1. That is what, right? When you add 0 plus 0, 0. So then 2 plus 3 is 5. 3 minus 2 is 1. So you got the output. Now you want to plot the vector in the graph. So very simple. What I will do here is, what you need to do, you need to provide this value as a vector and this value as one more vector and the output as a third vector. You need to provide it. Okay. So what I will do, I'll just copy the same code and paste it here. And I'm going to include, just change the values 2, 3, and here 3 minus 2. And the third one is you have to provide these values. So copy this one. So that is the resultant vector. You have to provide, it will not calculate. So you just to provide here as 5 and 1. That's why we just perform first addition. Later, what are the values you achieved? On that values, you are plotting the graph. Okay. Now try to run this cell. Try to run this cell. You can see the plot. Yes.
Yes, ma'am. Yeah.
You can give different colors also. If I'm giving the resultant one as a red color, you will get the resultant for one as red color. And now I'm going to perform the subtraction. So just to copy the same thing, I have taken the same values. So subtraction of 2 vectors. Subtraction of 2 vectors. So what I'll do, instead of keeping the plus symbol, I'm just going to give the minus symbol. I'm just changing the variable as a diff. So now you print it, the value you will get it here is -1 and 5. So with the help of these values, you are going to plot the graph. So just to copy this snippet and paste it here. And this resultant one, you have to provide the values. So just visualizing that one, that's it, 5. And if you want red color, you can give it. Now just to run and check it, how the plot will be. See here, you will get this kind of plot only. But for understanding the main thing for MCQ, that is what? Whenever you are subtracting the vector from one vector, that the second vector should be reversed. Okay, that should be compulsory reversed. Okay, the output you can see it like this, but it should be reversed. Okay, ma'am. Next concept here is multiplying a vector with a scalar. Multiply a vector with a scalar means you are multiplying a vector with any one number. Then what happens? The size of the vector will get increases. If you are, that is what, right? The size of it, if it is a positive, it will increases. If it is a negative, it will decreases from the given vector. For example, what I'll do here is, let us create one array. So let us take like this. X1 is equal to np dot as array. So you provide origin values 0, 0. Then I'm providing 2, 3. This is a one array. Okay. Now what I need to do, I want to multiply it. So x2 is equal to, with 2 I want to multiply it. It's a scalar. Yes or no? 2 is a scalar and I'm multiplying this scalar with a vector, that is x1. So what is the result you will see? Let's see. So print, what is that value variable? X2. So now this is the value you are getting. So now what I'm going to do, I'm going to plot the graph for this. So just to copy this snippet and paste it here. So we just need two vectors are enough. So now what I'll do, what is this output? So 4, 6, 4 and 6. Now just run and check it. Usually see here, this is our original one. This is original vector. If you are giving the positive scalar, the vector is getting increased. Yes or no? It is getting increases. And for suppose, I'll just copy the same thing and I'm adding one more cell down. And what I will do here is, you just copy this code also. If I am multiplying with a negative scalar, for example, if I am multiplying with 0.5, minus 0.5, okay, I am multiplying this vector with a negative scalar. That time, what is the output you will see? You are going to see these values. You are going to see these kind of values. Okay, you don't consider these values. So usually you are getting in this way only. So now, when it is like this, what you need to do, you need to reverse it. You need to reverse it. That means it is going to become 1.5. You need to reverse it, means it is going, usually this will be like a -1 and minus 0.5. So it will be reducing the actual size of the vector. So now just to plot these values, just by providing -1 and minus 1.5. Just to try to run and check it. You can see the value is coming which side? Opposite side. Is it coming? Is it just coming opposite side? Yes, sir. What is the actual size of this vector? This much length. When you are giving that negative value, the size of the vector is reduced. Yes or no? Here you see the size of the vector is increased. If you are giving the positive scalar. If you are giving the negative scalar, it is going to be decreased. Dot product of two vectors. So dot product of two vectors is nothing but usually நம்ம vectors addition பண்ணும்போது நம்ம element wise பண்ணிட்டு இருந்தோம். So coming to the dot vector of two vectors, see here dot product of two vectors. So now coming here dot product it is coming from here to here. So this is one vector having 4 4 and coming to one more vector, it is 2 3. When you apply product in between this like this 2 3 dot product, you are providing the dot 4 4. How to perform the operation means you have to multiply these two things like 2 into 4 and you need to provide the plus operator when after multiplying this again you need to multiply these two values 3 into 4. So what is the value for this now? 8 plus 12, that is 22. Whenever you are multiplying two vectors with the help of a dot product, the output will be like a scalar. It is a scalar value. Understanding, ma? So what is the formula here means? What is the formula for dot product is a bar dot b bar is equal to magnitude of a bar, magnitude of b bar and cos theta. So actually this is the formula. So by from this we are just calculating in this way. Okay, Mama. So see here, if it is what is the matrix? What is the shape of this one here is 2 by 1. This is also 2 by 1. So whenever you are applying the dot product between them, you are going to get the result in the scalar format. Okay, ma. So idella you understand pannikonga so that whenever you are coming there, you will come to know why we are using these, why you are learning these concepts and all. Okay, ma. So dot product understand acha. Simple calculations understand pannikonga idla avladha. Clear?
Yes, ma'am.
Ma just calculations understand பண்ணிக்கோமா இந்த எதுமே கான்செப்ட் இல்ல just concepts and means calculations, that is nothing but concepts understand பண்ணிக்கோங்க. அடுத்து நம்ம எங்க யூஸ் பண்றோம்னு அப்புறமா பார்க்கலாம். ஓகே, support vector algorithm இருக்கு, அதெல்லாம் இருக்கு பார்க்கலாம். Okay, so the next coming to cross product of two vectors. Cross product of two vectors annappo you have to make use of கொஞ்சம் complex ஆ இருக்கும். So now you are having two vectors, so you have to provide cross symbol between the two vectors. So when you are performing the cross product between two vectors, the output will be like a vector only. So what is the formula for this here is a bar means magnitude of a cross magnitude of b. So it is like looking like this: I x-axis, j y-axis, k is nothing but z-axis. So here we are having I value in this one is 2 in the a bar. This is let's assume this one as a vector and this one as a b1. So here this is on x-axis and this is on y-axis. So 2 and 3. There is no z-axis, so you should provide a 0 here. And coming to this one, x-axis is 4, y is a 4 and z is a 0. So how to perform this one here is whenever here 3 categories are there, X, Y, and Z. You should alternate the signs. So if you are taking this one as plus, this should be minus and this should be plus. So how you have to, whenever you are performing here, this value should be ideal and it should be cross multiplied. See like this. So now 2 into, okay, 2 into, that means you have to provide this I value. I, so this is x-axis, right? So I, so this should be ideal. So means remaining things should be multiplied. So 3 into 0, that is a 0. Okay, minus 4 into 0, that is 0. Here, this should be negative, minus j. And this should be ideal. This value, and this value should be multiplied. So what is the value? 2 into 0 is 0, minus 4 into 0 is 0. And this is positive. So plus k, this should be ideal. We should multiply this. 2 4s are 8, minus 4 3s are 12. So now what is the value? This value will be 0 and this value will be also 0, plus k of minus 4. So what is the output? Minus 4k. That means you are having only the negative, means z-axis. You are getting the value in z-axis. So what is it? It is going to represent the vector. So on x-axis you have 0, y-axis is 0, and y-axis it will be like minus 4. Means you are going to get some kind of value. We'll see that one, where you will get the arrow. Okay. Understanding, ma? Yes? Clear? So what is the formula?
Fine. Yeah.
Tell me.
Yeah, calculation is fine.
Yeah. So now this is about cross product. This is actually two-dimensional vector. You can also, means two-dimensional vector means I'm having only x and y. So you can also perform in three-dimensional just by providing one more value here. Okay. So we'll implement, okay, practically we will do these things. Later we will discuss these things. So coming to the dot product implementation. Yes. Now we are going to work on dot product. So what I need to do here is, for creating the vectors, I need a NumPy library. So what I need to do here is, first you need to import a NumPy library. Import NumPy as NP. So first run this cell. Now I'm going to create two vectors. That is two-dimensional vectors. So let us take x is equal to, so from the NumPy library, I'm creating array. I already said that vector is nothing but it's a kind of an array. So now I'm passing a two-dimensional. So I'm going to pass two values. One is 2 and second value is 4. Okay, on x-axis I'm providing the 2 and y-axis I'm providing the 4. And coming to the y vector, one more vector, that is y is equal to np dot array of, you just pass some other values. Let us take 4, 4. You can write whatever you like it. So these are the some other values. Now what you need to do, you need to perform dot product. So for performing the dot product, there is a one function available in this NumPy library only, that is a dot function. So what I will do here is result is equal to, from the NumPy library, I am having a function called dot function. What are the vectors you have stored? Where you have stored that variables you have to provide it, x, y. So now just to print that result. So you can see the result as 24. I already said that whenever you are performing the dot product, it will return a scalar value. Okay. So now you can apply three-dimensional also. Now if I'm providing 2, 4, 5 and 4, 4, 3. So it will return some other value, that is 39. So how it is going to be calculated three-dimensional? Same process. When you are having a two-dimensional, how you will do? Just like that only. So 2, 4, 5 dot product 4, 4, 3. So how it is going to be calculated? These two values will be multiplied. Yes. Then plus operator 4 into 4 plus 5 into 3. Is it correct? Is it correct? See. Now what is the value of 8? 4, 4, 16. 5, 3 is 15. So what is the value? You will get it here, right? 39. So that is the value you are getting. So we are just implementing the mathematical way. But to implement this, we are having a direct function from the NumPy library's dot function. So you should not ask how this value comes, right? So this is the formula for getting the output. Understanding? Yes. Next, coming to the cross product. Coming to the cross product. For this also you have a formula, for you have a function. So let us take first two-dimensional. So what I'm going to do, you can take the same thing also, ma. What I'll do, I'll just copy the same vectors and I'll remove. First we are learning the two-dimensional. That's why I'm just removing the last values. So when you want to perform a cross product, you have a function called, what is that function? Cross function. From the NumPy library only. Result 1 is equal to np dot cross function, where you have stored your vectors x and y. So print off your result. So run and check it. You will have the value as a -8. But this is a vector only. This is a vector only. Okay. If you try to mention a three-dimensional, means three-dimensional values, you just provide 2, 4, 5, 4, 4, 3. You just apply this one. You are going to see the vector. Understanding what I'm saying, everyone?
Yes, ma'am.
Yes. So this is what dot product and cross product on the vectors. Okay. So the next thing we are going to learn more about a matrix. So I already said that a matrix is a combination of vectors, means where it contains rows and columns. So to know the how many rows and how many columns present in this, we can simply use a shape property on that data set. See here, when you are having like this, means two values in the first row and two values on the second row, we can say it's a 2 by 2. The first value is saying that you just understand about the NumPy library, that's it. So this mathematics, comes from the NumPy library only. I already said NumPy is nothing but mathematical calculations. Getting my point? We are going to work majorly on NumPy library only here. Okay, so see here, so 2 by 2 matrix. When you are having three values in the first row, second row, and third row, so here you can say here 3 rows and 3 columns. And the notation of this, see here, general notation m by n. That means in the first row, first column, first row, second column, first row, third column, and so on. Like this is second row, first column, second row, second column, like this. So you have to mention it like this only. Then coming to the what are the types of matrices you have, means we have two types of matrices. What is the purpose of using this matrix here is for initialization purpose. For example, whenever we are performing sum of two numbers, what we will do? We will be initializing the variable with 0, because we don't know what will be the sum for when we perform addition on those two numbers. We don't know what will be the value. So what we will do? We will initialize that variable with 0. So just like that, whenever you want to perform some kind of manipulations, you should initialize it with some values. Either it may be like a 0 matrix, or it may be like a identity matrix, or it may be like a I matrix also. We learned in the NumPy library already. So null matrix is nothing but where that matrix is having all zeros. Okay, based on your operation matrix. Okay, for example, if you are having 2 by 2 matrix, then you initialize that resultant matrix with 2 by 2, either with the 0 matrix or identity matrix. Identity matrix is nothing but where it has a ones on diagonal way. Can you see? So, but remember, whenever you are using the identity matrix, where it should contain equal number of rows and columns, that is compulsory. Then only you can see the identical values. Otherwise, you cannot see. So these are the different types of matrices. So we have learned already this one in the NumPy library. Let's take x is equal to combination of one dimensional. I can make it like a 2-dimensional. Now see here, I'm making 1, 2. This is one list. Again, I am making 3, 4. This means this is one dimension and this is one more dimension. The combination of one dimension, I can call it like a 2-dimensional print of x. Now you can see here, it is coming. So it is like a list actually. Now what you need to do, you have to make it like a NumPy library. So mp dot array, you should typecast it. Okay. Now you can see it is a 2-dimensional array. It's nothing but a matrix. It's a matrix. You just check it. Print type of x. Print type of x. See here. It's a NumPy array. So it's a 2-dimensional. If you want to know the type, what you can say? X dot end. Okay, 2-dimensional. Yes or no? Now what you need to do here, you need to check the shape also. X dot shape. Now you can see it's a 2 rows, 2 columns. So we have learned all these things. If you know null matrix, what does mean by null matrix? So where it contains all zeros. So we have learned that also. Y is equal to, from the NumPy library, we are having a function called zeros. So you should provide dimensional. I want a 2 by 2 means 2 by 2 in 2 by 2 matrix. I want all zeros. So print of y, you can see you will get a null values. Usually it will give float values. Then what I said, you should typecast it using the d type is equal to int. So zeros, you have to use the zeros function. To get only the diagonal values, the rest and all zeros. Then we have to use this I function coming from the NumPy library. np dot I function. You should provide the size, means how many rows, how many values. It should be like a square or like a equal number of rows and columns. If I'm providing 4 by 4, that means 4 by 4 this one. So now try to print that variable. You can see the diagonal values on all be 1. It's like float values only. Basically it will generate a float values. If you want to generate in a what I can say, if you want to generate it in a integer values, then you should provide a d type is equal to int. Okay, you should provide d type is equal to int. So now you can see it is going to provide a integer values. If you want to get only the ones, usually when we want to perform a multiplication, we will not be initialized with zeros. It should be initialized with 1 only. So that time this initialization function is necessary in the matrix. So b is equal to np dot ones function. You should specify the size of that matrix, that is 2 by 3. So print of a b, you can see it is going to return a all ones. It is in a float data type. If you want it in integer, I said already, basically default will be float. If you want to convert to integers, you should use this attribute d type and give the data type of that value integer. Now this is what the types of matrices. And transpose of a matrix is nothing but the row values will be converted to the columns and column values will be converted to the rows. That is what a transpose. This also we learned already. So transpose function or a transpose, that is we have seen while learning the NumPy library. So transposes we have learned already. See here. So transpose is nothing but you can use either transpose function or t. See here t, a1 dot t. Okay, so that the row values, see 1, 2, 3, 4, it is in column wise. Okay, this is the row values. So these row values will be in column. And these column values will be like in row. So 1, 5 in row. 2, 6, this is one column. This is in second row. This is a third column. It is in third row, like that. Transpose. So now see here, let's generate what is meant by transpose. So let us take, you can create a NumPy library. So z is equal to np dot array function. So let's take array function. I'm going to provide 2 by 2 matrix. So 2, 3. Later I'm providing 4, 5. So you are making 2 dimensional. So I already given hint that 2 dimensional means it should have 2 square brackets. Now print of z, you see here, this is your matrix, 2 by 2 matrix. Now you need to make what? You need to make row values as columns, means instead of 2, 3, it make it like a column, and 4, 5 like a column. So what I can do here is simply z1 is equal to, you can provide a transpose function from coming from the NumPy library. Transpose of from what matrix you need to convert it, z variable z1. So if you make print of z1, you can check it the values. This 2, 4 is now in row wise. This 3, 5 in a row wise now. Okay, this is how you can perform transpose on the matrix. And coming to here, there is a, you can also use a matrix in the machine learning. So usually our data set is nothing but a matrix only. So if you are taking this data set, how many rows and how many columns? You are going to represent, this is a tabular format where it contains rows and columns. Indirectly, I can say it like a matrix. So how many rows you have here? 1, 2, 3, 4, 5 rows. sorry, 5 columns. How many rows you have? Totally 12 columns. Sorry, 12 rows and 5 columns. Understanding what I'm saying, everyone? Yes, ma.
Yes, ma'am. Yes, ma'am. Including A, B,
Now
C, D,
learn
E.
what
It's yeah. Okay.
and what called rows. These are all called column names. A, B, C, D, E. That are columns. 1, 2, 3, 4, 5. That is a rows. So when you apply shape property on this matrix, that means data set, it is going to give a size of that matrix. Okay, matrix nothing but the data set. Okay, yes. Now we are going to learn a matrix operations. That is how to add two matrices, how to perform subtraction on the two matrices, how to multiply a matrix with a scalar value, how to multiply two matrices. This is very much important. Okay, see, when you are performing addition, okay, remember, two matrices can be added only if they have the same shape. If it is different shape, it is not possible. If it is 3 by 3, it should be also 3 by 3. If it is 2 by 3, it should be also 2 by 3 only. 3 by 2, 4 by 2, it is not happening. It throws an error. Okay, so same shape, that is both the matrix should have the same number of rows and columns. Then only you can able to perform. Okay, so coming to the subtraction, for subtraction also it should have the same shape. That means it should contain same number of rows and columns in the both matrices. Then only you can perform subtraction. Then scalar. So you are just whatever the type of matrix it may be, you are multiplying with the scalar. It's not at all issue. Okay, so scalar means matrix is nothing but what? It's a combination of vectors. See here, vectors are a type of matrix with either one row or one column. Okay, so I'll just show all the practically. Next, multiply two matrices. This is very important actually. So whenever you are multiplying the two matrices, make sure the first matrix column and the second matrix row should be same. Then only you can able to multiply. See here, the number of columns in the first matrix be equal to the number of rows in the second matrix. Then only it can be multiplied, so that you will get the resultant matrix as 2 by 2. How you will get this 2 by 2 means the first set, this here, the first the row of the first matrix and the column of the second matrix will be the result. The resultant matrix will have the same number of rows as the first matrix and the same number of columns as the second matrix. If it has a unequal, means different categories, like if it is different, means the first matrix column and the second matrix row is different, then you cannot able to multiply. It throws an error. Okay, this is the rule actually when you are multiplying the two matrices. Okay, first I'll implement the previous one and I will come back here. So now we are performing matrix addition. Okay, matrix addition. This is very simple. We have seen already this and all. Simply, I'm going to create two matrices just by using the NumPy library only. So let us take A is equal to np dot array function 2 by 2 matrix. So I'm just providing list inside a list, two lists I'm going to provide. So let us take a 2 comma 3. The values you are Vishma. I'll just taking the simple values. So this is a 2 by 2 matrix. I'll just copy this. I'm going to provide one more matrix. Remember, it should have equal sizes 6 comma 7 and I'm providing 8 comma 9. So now I will providing the plus operator between them. So addition is equal to A plus B. Here I have to change the variable name B. So now print that variable name, print addition. So now run and check it. So see here, it is going to multiply how? Element wise. 2 plus 6 is 8. 3 plus 7 is 10. 4 plus 8 is 12. 5 plus 9 is 14. So if you want to get properly, you just type print A. Individually you type it. Print A. Then print B. Print B. So now see here, these are the values. Means first row, first column value of the first matrix. First row and first column of the second matrix will get added up and you will get the resultant matrix. For suppose if I am having something like this, means the first matrix is 2 by 2 and second matrix is 3 by 3. Is it possible to do? Means it throws an error. You cannot able to do it. Because the first matrix is having the size 2 by 2. When coming to the second matrix, the size is 2 by 3. That means 2 rows and 3 columns. 2 rows 2 rows and 3 columns. It is not possible to perform a addition. Same way, if you want to perform subtraction, so it should be having a same size, subtraction. So I'll just change these things, copy and paste it here, and you should provide a minus symbol. If you are having a different matrices, it is not possible. You cannot do. If it is having a same matrix, it is also works like a element wise only. So now see here, 2 minus 6 is minus 4, 3 minus 7 is minus 4, 4 minus 8 is minus 4, 5 minus 9 is minus 4. Same shape should be present. Otherwise, it throws an error. Getting my point? Yes?
Yes, ma'am.
Yeah. So the next thing here, addition and subtraction is done both at a time. So otherwise, we'll just copy it and just write it here. Matrix subtraction, and I'll just redo done. Okay. So now this is addition and something is wrong. Here it is. Okay, run it. Now here addition 1 is done. Oh my God, where I pasted this? I didn't paste it here. Yeah, now I pasted. Okay, so this is about subtraction. Now the next thing here is multiply matrix with a scalar. Multiply matrix with a scalar. Okay, so now see here, you just create. I just take this matrix only, 2 by 2 matrix, or you can use 3 by 3 matrix also. So if I'm providing some other value here, like 2 by 3 matrix, this is a 2 by 3 matrix. You can check it like this. Print A. If you want to know the shape, you can make use of print A shape property. So now here 2 rows and 3 columns. 2 rows and 3 columns. The shape you got it. Now you are multiplying with a scalar value. So what I will do? Result is equal to 5 into. See, whenever you are performing the multiplication, what you have to do here is you should make use of star, that A variable, and you print it with the help of result. Now just run and check it. So now see here, it's element wise. 5 2s are 10, 3 5s are 15, 5 4s are 20, 6 5s are 30, 4 5 4s are 20. So like this it is going to come. Okay. So here, instead of using these symbols, we have learned already some functions like add function, subtract function, multiply function. In the NumPy library we have seen. You can make use of those functions also for performing multiplication, subtraction, and addition. These also you can make use of for these operations. Okay, just try that or not. So the next thing, we are multiplying, okay, 2 matrices. Whenever you are multiplying the 2 matrices, I already said that the first matrix column and second matrix row should be same. Okay, if they are same, the resultant will be the first matrix row and the second matrix column. Shape will be that one. So let's create 2 matrices. I'm going to make use of these 2 matrices only. Okay, and I'll copy and I'll print those 2 matrices. Whenever you want to perform, okay, whenever you want to perform multiplication between the 2 matrices, we are going to make use of the function called a dot function. What is the function we will use here is dot function. Dot function, simply dot function, we will make use of it. So now what I'll do here is a resultant 1 is equal to, so user from the NumPy library, we are having a function called dot. What are the, where your vectors are? In A and B. So now try to print that resultant variable. So try to print that resultant variable. So now run and check it. So these are the values. How it is going to be multiplied? How it is going to be multiplied? What is the formula we have said here? How it is going to be multiplied? Same in the dot product, how I have said. So 2 into 5, like that only. It is going to be multiplied in the dot product we have learned, right? Same way it is going to be multiplied. Understanding, your matrix is having A, B, C, D values, first matrix, and the second matrix is having E, F, G, H. So the formula will be AE plus BG, then AF plus BH, like this. So AE plus BG, AF plus BH. Okay, then here also same thing. So CE plus this one DG. Then CF plus a DH. This is the formula. So now just make use of this and you will get the output. So let us take these values. Okay, with different color. Now here the value is a 2, 3, 4, 5, and here is 6, 7, 8, and 9. So just to do this one. So 2 6 are 12 plus BG, right? So 3 8s are, what is the 3 8s are? 3 8s are 24. Yes. Then here AF, that means 2 7s are 14 plus BH, 3 9s are 27. Then CE, 6 4s are 24 plus DG, 5 8s are 40. Then CF, 7 4s are 28 plus DH, 9 5s are 45. So output will be 36, 41, this one 64, 60, 73, right? 73. So this is your output. You have to apply the dot product whenever you are performing a multiplication on two matrices. Getting everyone understood till here? Now what is the matrix, this one? 2 by 2, this is 2 by 2. That means the first matrix column is 2 and the second matrix row is 2. So then you can perform multiplication. The output will be 2 by 2. You got it, the same thing. If suppose, first suppose what I will do, see here, if I'm adding one value here, let us take, I'm just going to add 1. Here I'm taking something like 5. So how it should be like, how it will be like? So the value will be like 2, 3, 4, 5. And this will be like 6, 7, 1, and 8, 9, 5. So what is the matrix for this shape? 2 by 2. This one, 2 by 3. Correct. 2 rows and 3 columns. Here you have equal number of columns in the first and equal number of rows in the second. Then what is the resultant matrix for us is 2 by 3. Because this and this, 2 by 3. So now you can check it here. You can check it. Perform dot product only will apply. So just run and check it. So now see here, you are getting 2 by 3. If you want to check the shape also, you can check it. Print resultant 1 dot shape. So you will get what is the shape? 2 by 3. When it is not possible means if it is having unequal number of rows from second and first matrix columns. That means if I am having a one more row, let us take a one more row with the values 3, 2 I'm having. So now see what will be this one. So now see here, this will be like 2, 3, 4, 5 and this matrix will be like 6, 7, 8, 9, 3, 2. What is the shape? 2 by 2. What is the shape? 3 by 2. Here these two are unequal. Then we cannot perform multiplication. That time it throws an error for us, as see here. It throws an error. It is not possible. Okay. So 2 by 2 and 3 by 2 not aligned. Okay. It should be having, that rule should be satisfied. Then only you can perform the dot product on it. Clear this matrix multiplying on two matrices. Everyone.
Yes, ma'am.
Clear? So this is all about vectors, means linear algebra is done. By this we have finished our linear algebra. Very basic things. If you know more about a NumPy library, then it is very simple. Just this calculations in this very important concept here is just understanding about the vector, scalar, and matrix. That's it. Completely using the NumPy library. Okay, so this is what a matrix concept. Yeah, this is what done. Okay, hope you thoroughly understanding the concepts. If you are having any doubts, comment below. Still who are not subscribed to my channel, subscribe to my channel and hit the bell icon for more notifications. Keep supporting. We'll meet you in the next video. Have a nice day. Thank you. Bye-bye.